All right, I got about 30 problems coming your way, 50 to 80, 51 to 80, and I've got 30 minutes to do this. So 1 minute per problem, and let's get after it. All right, just for practice sake. All right, so that's a new problem here. All right, so cosine of 5 pi over 3. There's pi, the top half of the circle. I'm going to get a good drawing here, breaking it up into 3 parts. This is 0 pi over 3. As I walk around the circumference of the circle, I need the bottom half because I got to get to 1 pi over 3, 2, 3, 4, 5. I'm here. Draw the perpendicular back to the x-axis. Hypotenuse is still 1. We can see our 60-degree angle here, which is what pi over 3 is. And therefore, minus root 3 over 2, 1/2. And so the adjacent to hypotenuse ratio is 1/2 divided by 1, which is 1/2. That's what that answer is. I wish I could do a little bit more than that, but I won't get any practice your way unless I attack it that way. I'm going to do number 55 right away. So x equals 4 is a root. If x equals 4 is a root, then x minus 4 is a factor. And so now I got to find the other factors and then find the roots of those other factors. I need x squared. X times x squared is x cubed. But now I have minus 4x squared. I need minus 10x squared. So I need minus 6x because that gets me minus 6x squared. So now I have that and I have that. I have minus 4 times minus 6, which is positive 24. I've got to get to 17. How do I get from 24 to 17? I have to go down 7. I think I counted that right. And minus 4 times minus 7 is 28. So now I have this is the same as that calculation. So what are my roots? 4, and I got to factor this now. X minus 7 times x plus 1. So my other roots are 7 and negative 1. So those are my answers. That's problem 55 on the worksheet you did today. Okay, so if you're having trouble with that, play this a couple of times. ln of 2 over 3 is the same as the ln of 2 minus the ln of 3. Using log rules, I get 0.7 minus 1.1, which is negative 0.4. That's my approximation. In order to see those log rules, I will do the following. I will rewrite 2 over 3 in e notation, which is e to the 0.7 is 2, and e to the 1.1 is an approximation for 3. I'm seeing e to the 0.7 minus 1.1. It looks like a division problem is a subtraction of the exponents. A division problem in e notation, we're looking at a subtraction of exponents. There it is. That is the ln, right? ln is base e. So I'm really saying e to the x equals e to the 0.7 minus 1.1. What is x? X is 0.7 minus 1.1, which is the ln of 2 minus the ln of 3. And it came from a division problem. All right, so you might have to think about that quite a few times before you own it. But we're at that stage of the term where I'm hoping you leave my class knowing your rules of exponents. All right, so while we're at it, why don't we do this one then? Let's do 54. 3 ln of 5 plus ln of 2. I know that's the ln of 250 just by looking at it, because I know that's the same thing as the ln of 5 cubed plus the ln of 2, which is the ln of 125 plus the ln of 2, which is the ln of 250. Now, to help you see that log rule, I'll do the addition here quickly with a different problem. Log base 2 of 2 plus log base 2 of 4 is equal to log base 2 of 8. At this stage of the game, the numbers should speak for themselves. Written this way is a multiplication. That's why I can do that. Seeing the multiplication of 3 here is going to be a little bit harder. So let's do this organically. That is equal to 125 times 2. 125 is 5 cubed times 2. I know 2 is e to the 0.7. I know that. And I know that 5 is e to the 1.6, and I'm cubing that. Well, you tell me what kind of exponential activity you see. I see 3 times 1.6 plus 0.7, which is 4.8 plus 0.7, which is approximately 5.5. But what I was really highlighting was getting this to be written that way. So what do I learn about this? That 3 can go here. Because when do you multiply? This is a multiplication of exponents. Remember, ln of 5 is an exponent. So where do you see that multiplication? I hope you see it right there. And 5 cubed is 125. Okay, doing my best to show you what you need to be thinking about. You might need to think about it for longer. Tangent of 5 pi over 6. 5 pi, there's pi, broken up into 6 parts. Good drawings get good answers. I'm at the 5th, which is over here. Remember that's 0, 1, 2, 3, 4, 5 pi over 6. 5 times 30 degrees. I'm at 150 degrees. Hope you saw most of that. Okay, 1, 2, 3, 4, 5. So I'm here. I'm seeing a 30-degree angle, right? Pi divided by 6, 180 divided by 6, 30 degrees. I'm looking for the tangent. I like to take that and double its size. So the hypotenuse is now 2. That's negative root 3, and that's 1, because this is a half, right? And I'm doubling. This is negative root 3 over 2. Those are your famous ratios you don't need a calculator for. Tangent is opposite. The reference angle's over here, 30 degrees. Opposite over hypotenuse, over adjacent. That answer is equal to negative 1 over root 3. Root 3 is about 1.73, by the way. All right, so what's the domain of the ln function? Well, you got to know what the ln function looks like. All right? And if you want to graph the ln function, let the parentheses equal 0, let it equal 1, and let it equal 3. When it's 0, it's undefined. When it's 1, the ln of 1 is 0, so it goes through the x-axis at 1, 0. And the ln of 3 is 1.1. So that's that altitude. This altitude is 1.1. That's what the ln function looks like. So what x's can I use? I don't see anything over here. I see all my x's as being what? Bigger than 0. So the domain of that is you got to know that the parentheses of a logarithm, whatever's in the parentheses has to be bigger than 0, or you're not doing the inverse of growth and decay. If something's growing, there's something there. If something's decaying, there's something there. What's the inverse of time to something? Something exists. Well, if it exists, then it better be positive. All right, so that's the domain of that. Average rate of change. They believe the function was x squared. Can't answer this question unless I give you a function. So what's the average rate of f of x equals x squared from negative 2 to 3? All you want to do is figure out where you are at negative 2. I think you're squaring it. You're at 4. Where are you at 3? I think you're at 9. And the average rate of change is rise over run. It's the slope. Well, how did I get from 4 to 9? I went up 5. How do I get from negative 2 to 3? I went to the right 5. So what's the slope between these 2 points? 1 to 1. It's a 1-to-1 ratio of change. All right. And I'm asking that question because in my calculus classes, my kids did not know that coming into the classroom, and I think you should. Shouldn't have to waste time on that in the calculus class. Sine x plus 1, when is the sine function equal to negative 1? Sine function are the heights in the unit circle, right? If that's x, then that's the sine of x, and that's the cosine of x. That's 1. So when are heights equal to negative 1 in the circle? Straight down, 3 pi over 2. So that's that answer. X equals 3 pi over 2. What is 3 pi over 2? An angle. And if I put that angle in, I get this ratio, negative 1 to 1. The height's negative 1, the hypotenuse, the width is 0. It can't really draw the triangle. All right, so that's that one. When is the cosine equal to 1? Well, cosine is the width. So when is the width equal to 1? Right there at 0. And if you put 0 and if you put 2 pi, I don't care. As long as I see that one, I'm happy. But in the unit circle, those values take us back to the max. That's one period. So there's your cosine function. It's a sinusoid. 0 gets you 1. Very important to know because 0 is easy to work with. It's how we're going to do a lot of our graphs. All right, so this is old hat. Do you recall how to factor the sum of two cubes? You need the cube root. Y is x3. You need the cube root. 3y, excuse me. That's got to be a 2. Right, 2 cubed. So there we go. That's the first parentheses. I have it now. Everything else is based on what you've got here. I got to square that. 25x squared. Up, square it, fourth. All right, I got to square that. Well, I got to do the 15 becomes negative 15 x squared y. And then I got to square the last term. 9y squared. You were doing pretty well with that at midterm, so hopefully that comes back to you. All right. Next problem. Can we see it? Didn't even see that one. Sorry. I'll be more careful going forward. So I'm going to square this. If I square that, I get 3x minus 3. Okay, and that has a x-intercept. All right, so -1 gets us 0. And if I hit that with a square root, it's going up like that. And what's x minus 1? X minus 1 goes through at +1, 0. And I got a linear function. It looks like I have one answer and one fictitious answer. One fictitious answer, extra answer, extraneous root. So if I square this, then I got to square this side. Did I have x minus? Yes, that squared is 3x minus 3. This squared is x squared minus 2x plus 1. And yes, you have to know how to square binomial. So 0 equals x squared minus 5x plus 4. That means x minus 4 times x minus 1 equals 0. 4 works. That would have been that one. This one would have been -1. That's the fictitious one. So if I put 1 in, it shouldn't work. Oh, but it does. So hang on here. Oh, I misstated this one. Right? I said -1. So there's my careless error. That shifts over to here. Right? And then this would have a different slope. This goes up quickly and then like that. So there, 1 did work and 4 did work. Okay, so it's very important to know when you're wrong. I figured out, I saw something, I knew I was wrong. I went back, picked up a careless error. All right, so let's move along. How much time do I have? I got to stop this at, let me check the time. Okay, I'm on pace. I got 20 minutes. As I go to infinity, this goes to 5/2. Hopefully that's a 10-second question. No, this is an exponent of 1. So excuse me, didn't look at it. So that goes to 0. Why? When we put really, really big numbers in, I don't think those matter. And so we get 5x over 2x squared. I hope I didn't copy it wrong. And so I reduce that. Let's make this number bigger and bigger and bigger. Let's put a 1 in there. Let's put a 2, a 3, a 4, a 5. Eventually, we're getting what? Put a 1 in. Put a 10 in. Put 100 in for x. So on and so forth. So where's my function headed? It's headed to 0. Okay, so anytime this exponent's bigger than that, this generally happens. All right, we've already looked at logs, so what do I have here? I have a product. So as a single log, I could write that as log base 2 of x squared minus 6x equals 4. And if you don't understand that, go back and look at the first 5 problems I did. All right, so now I'm going to rewrite x squared minus 6x. The inverse of log base 2 is 2 to the. That gives me x squared minus 6x minus 16 equals 0. That gives me x minus 8 times x plus 2 equals 0. The only answer I have is 8 because I can't use -2. That can't be negative. So we're having a repeat discussion of the first 5 problems. There are one of them. Piecewise function. All right, piecewise function. Show you how I do these problems. I know that's V-shape up, so my first piece is a negative slope. And I'm just going to write -2 times 2x minus 10 plus 3. 2x minus 10 is a linear function that passes through 5, 0. Okay, and if I slap that with an absolute value, like I have over here, then the negatives become positive, and this thing right there is like a hinge at x equals 5. Right? And I'm on the left side of 5. That's when it's going down, and that's where the hinge is. And then the hinge goes up. I don't like the way I stated that. Okay, but I'm having a lot of wrong answers with what's over here. This is a linear function that equals 0 at 5. It's V-shape up, the left side, then the right side. When this is negative, happens for numbers less than 5. And what happens to those negatives with the absolute value? They become positives. Okay, so there you have that. Now, if I want to find out, I know my vertex is 5. If I want to find the critical numbers that equal 19, then I'm just going to solve for 19. I'm going to bring 3 over. I'm going to pretend to use this one. I'm going to get one of my roots. I'll use that one, and I'll set it to 19. We can do it here. Take 3 away, 16, divide by 2, 8, add 10, 18, divide by 2 is 9. Okay, remember the vertex is at 5, and I went 4 in that direction. Then 1 is the other root. I don't have to work harder than that. So I now know that this thing has solutions at 5 and at x values at 9, excuse me, 9 and 1. 9 and 1. Let's put a 1 in and make sure. That's -8, the absolute value of -8, 8, 16, 3, 19. Okay, it's good. And now I want what? I want to be bigger. And this is a V-shape what? V-shape up. Bigger. I'll make this height 19 because at 9, I'm there, and at 1, I'm there. This is 1, 19. This is 9, 19. These points right there. And I want to be what? Greater than or equal to? Well, greater than are these x's. Right? If this is 19, that x is going to get me something bigger than 19. This x over here is going to get me something bigger than 19. And these x's are going to get me what? Smaller than 19. So my answer is these two intervals. What am I seeing? I'm seeing -infinity to 1, and I'm seeing 9 to infinity. Every one of these x's is getting me something bigger than 19. So -infinity to 1, union 9 to infinity. Yep. Okay, that's that. All right, continuing on. Factor that, you pause the video, I'm just going to tell you what I see. Except this number's off. So therefore, -40, I wanted to write -20. So I'm probably giving you that. Now, maybe 40 can be factored. So maybe I did this trying to fool you with that. I'm not sure. So I got to look at the factors of 25, which are 1, 5, and 25. Is that all? I believe so. Okay. And I could have a 4a times an a. So I got to be careful here. So 5 times 4 is 20. 20 and 5 don't come out to 40, which means I really got to use 25. So I got to try a 2 and a 2, a 2 and a 2, 2a. All right. Did I try to fool you or not? Let's see. So 25, 5, not going to get 40 out of that unless this is 25 and 1. No. All right. So it must be a typo. So there's a typo on that. 3 classes, 3 tests, 3 answer keys, probably working too hard. Long time ago. So I'm changing this to -20. That's what I'll be asking you is, do you recognize a binomial square? That is now correct. All right. So apologize for that. All right. 3, 7. And I see a circle. Therefore, I know I got an x minus 3 squared and I got a y minus 7 squared. And I'm also looking at 3, 7 becoming 2, yeah, I can't imagine why. Whoa, boy, am I in a hurry, aren't I? All right, let's just say it's this problem right now, because that's not possible, 3, 7, 3, 7. So was it something, my eyesight, bad, could have been. Let's just do this problem. All right, so how do you get from 7 to 2? Okay, it's got to equal 25. Now, maybe I wanted an ellipse here where this doesn't change, but this does. Let's do an ellipse too. Let's make this one narrower. Okay, and let's just say that that is 3. How about we do 3, 5? No, 3, 9. 3, 9. Okay, so how far is it from 7 to 9? I guess I got to make that a 5 and that a 7. Yeah, oh, you can tell my brain's working. Now I've moved 2 units to the right, which means that this would be a 4, and 7 to 2, I've moved 5 units down, then that's going to be 25, and now it equals 1. Okay, apologies for going through as quickly as I am, but I'm just trying to get you a practice session. So that would then be an ellipse. All right. And we got 3 weeks to do a better job with that. So I'm sure we will. All right. Making your brain really work here on this test. I've said this a number of times, but I don't necessarily see eye contact when I'm talking about it. I see a couple of folks looking out the window at the ridge. So the question here is, write the equation depicted. Well, I certainly see a parabola. X minus 8 squared minus 2 gets the vertex. I know I'm going down. -2 to -12 is down 10 units. And the square change is 1. So it looks like that's this. 8 to 9, wow. And I think that parabola is intersecting a height of -12. Yeah, that's what I'm seeing. Yeah, I'm just seeing a parabola. So if I erase that, I've asked you to write these. So you should be able to do that, I think. And I think we should know that a straight line is a graph, and this is -12, and this is y equals -10, x minus 8 squared minus 2. And what are we doing? We're looking at the graph superimposed on each other. We're looking at a graphical equation. And that's what I'm hoping you can write. I think it's important that you know that most of, I don't want to say all, because I don't think I can break this rule, but I think at this level, every equation you're solving is the intersection of 2 graphs. I think that's important to know. All right, let's get rid of that. I think we're going to get this done in the amount of time given. All right, so that's done. The inverse. Well, what's the inverse of going from X to Y? Well, we plug numbers in, we get numbers out. And whatever number goes out becomes the input of our new calculation. So this is the output of this calculation. Log base 4 of x plus 3 is equal to 3. Okay, so how do I do the inverse of that? It's not a friendly number, but you got to know the inverse of log base 4, which is equal to 4 cubed. Oh, that's actually a nice number. And now I have to subtract 3 from 64, and it looks like my answer is 61. So what is the inverse of 3? 61. Let's actually do the inverse. The inverse. Let's solve this for the letter x, which is going to be the output, if I can find the right number. All right, so what operations would I do? I think I'd do 4 to the x, right? So I think I'd subtract 3. All right, let's drop 3 in. 64 minus 3. Sure looks like it's 61. I moved that, so I should get rid of it. And that's what I'm dropping in. The input was the old output. Good to know for your SATs. You actually have to think about it. Doesn't come easily. You got to think about it. All right, E notation. Well, 2 is e to the 0.7. So I think multiply here, which means that becomes 0.7. And I guess I'm asking you your 4th grade math. 0.7 divided by 0, 0, 0. 3 0 places in this direction. It's going to go there. All right, but I haven't done it yet. All right, so the answer, 55e to the Okay, let's actually do it. 1, 2, 3, 3 zeros, 007. It should have been 0007. All those movies were wrong. 0.1237 x. That's pretty much the same thing as this function. Well, I guess it was a t. All right, so let's change that to a t. Those are pretty close to being the same thing, except the world works in E notation. So we want to get familiar with it. We want to get familiar with it with some numbers. So I can see a doubling every 10, 100,000 years, right? If that was coming my way, I'd have a feel for it. All right, so I think this was going to be greater than 0. I believe that's what's on the sheet. So we have to look at 5 as a root, and it's going to change signs at 5. This parentheses is going to change signs. If I put a 6 in or a 4 in, I'm going to get a sign change right here at 5. All right? At -3, I'm not going to get a sign change. Right? I don't care if I put -2 or -1. If I'm squaring, I'm getting a positive answer. I'm getting 0. Why don't we say or equal to so I can make this a little easier? And at 6, wow, that's pretty close. So not drawn to scale necessary, but there's going to be a sign change there. Now, if I put a really big number in, like 1,000,000, that's a positive, that's a positive, that's a positive. Sure looks to me like that's true. I think I'm going to get a false. I think I'm going to get a sign change when I put 5.5 in. 5.5, that's still positive. 5.5, that's still positive. 5.5 minus 6, I got a sign change. And so that product is not greater than or equal to 0. No, I think this one will be. -3 to 5, let's put a 0 in. 0 in. -10 cubed is a negative number. 0 plus 3 squared is a positive number. And 0 minus 6 is a negative. Now this time, that didn't change. That didn't change. I got a sign change at right here when I put a 0 in. When I put a number bigger than 5, but now when I put a 0 in, I get a negative times a negative. Yeah, that's bigger than 0. That was true. This will be true. You check it out. So your answer is -infinity. And because I said equal to, I can also include that, and I can include 5. Including 5 is a bracket. So that takes care of this entire interval, which is true. False from 5 to 6. So union 6 to infinity is my answer. What did the graph look like? I get what looks like the behavior of these functions. Behavior of that is linear, so it does this at 5. It's a cubic, so it's going to have a cubic look to it. I'm not going to spend much more time than that. But where am I greater than or equal to 0? There's only one place I'm not, which is over here. Right? And we can see the x values, hopefully from a graphical position as well. It's important that you learn that skill. So I'm putting it in front of you so you learn it. All right. Tangent of -3 pi over 4. Okay, so tangent pi over 4, 45 degrees. I want -3. So I'm going to break it up into fourths. That's pretty good drawing. -1, -2, -3 is here. Straight up. Those heights and widths have the same magnitude, and they both happen to be negative. So I'm doing -h over -w, which is 1. What was -h? It was -√2 over 2, which is approximately -0.71. I think it's important you know that. What was the width? -√2 over 2. And so height divided by width, sine of the function divided by the cosine, 1. 6 minus 2i squared is 36. -12 doubled, -24i. Squaring -2i squared plus 4i squared. That's -4, 36 minus 4, 32, -24i. Okay, getting there. Do I have time? 11 o'clock, I'm out of here. I have 3 minutes. Come on, Renee. 3 minutes, x to the 4 minus 6. I see a difference of 2 squares. X squared minus y cubed times x squared plus y cubed. Is that all it was? That's all it was. So let's get rid of that. I probably wanted to give you something that morphed into a cubic, but the heck with it. Subtracting 5, dividing by 6, inverse of E, ln, approximately 1.6. So that's not too bad. Trying to find the roots. Well, I see a 0 here. Let's make this side 0. Let's get rid of the 7. Let's leave the plus minus 2i on this side. Let's square both sides because I'm after a quadratic. Let's square that. Let's square that. So this on this side becomes positive 4i squared, binomial squaring again. Boy, it's really helpful if you can do that quickly. 4i squared is really negative 4, so I'm going to add negative 4 to this side. And there's my answer. Okay, we're here. It's good if you know your perfect squares. 5 times 4 times 3, minus 3 times 9 times 3, minus 20 times 16 times 3. What's this one become? Square root of 4 is 2. Square root of 9 is another 3. Square root of 16 is another 4. They're all root 3s. 10 root 3. Minus 9 root 3. Minus 80 root 3. God, I think I did that one for somebody in class, and I don't remember minus 80. Hope I didn't copy that wrong. Doesn't matter if I did. All right. That's the problem I ended up doing. It was probably a 2 there. 10 minus 9 is 1. 1 minus 80 is minus 79 root 3. At least you got a little practice on that. All right, so what are the roots? If you've been doing the videos, then you should know we're measuring from 3. You should know that the roots are when this intersects at 0. I don't see that happening, so I have an imaginary square root over here with a plus minus in front of it. How do I get from negative 5 to 0? 5 units of change, imaginary, imagining it goes in this direction. And I got an a value of negative 2. So it was really up 5, dividing by negative 2. That's really the first step. And then knowing that that's imaginary. And I finished up at exactly 11 o'clock. Goodbye.